Okay, good morning to all of you. This is last technical session of this 5 days training program. The topic is climate risk scenario for agriculture. Today we have with us Dr. S.T. Attri sir. I would like to introduce our today's speaker, Dr. S.T. Attri sir. He is presently working as an additional director General of Agrometeorology, India Meteorological Department, New Delhi. His areas of interest include climate change, environment, urban meteorology, agromet modeling, and international activities. He has been member of Commission for Atmospheric Science Management Group of WMO, Geneva, Switzerland, primary contact of Global Atmosphere Watch in country and expert member task force of Global Framework for Climate Services of WMO, United Nations. And he has felicitated and awarded commendation certificate by Honorable Prime Minister of India in 2007 for his contribution to the work of International Panel on Climate Change (IPCC), which is the joint winner of Nobel Prize in 2007. Uh, he has served as a member of Environmental Appraisal Committee, Thermal Power Industries, Mining and Coal Mining of Ministry of Environmental Forest and Climate Change for environmental clearance. Westward upon West IMD officer in 2010 and Pride of University in 2018 by GJ University of Science and Technology. Participated and presented paper in many national, international meetings, workshop, conference on agromet, environment, climate change, data management, etc., including Congress and Executive Council of WMO, session of Regional Association, Technical Commission, WMO, IAEA meeting of expert, and he has also served as a chairman, reporter of different working groups. Published more than 110 research papers, met monograph, books, reports in national and international journal. External expert on the board of postgraduate studies and research in environmental science and engineering at IP University, New Delhi, GJ University, Hisar, and MDU Hisar. Presently, he is executive editor of international journal Mausam and referee of many national and international journals. Uh, Sir, it is honor and privilege for me to welcome Dr. S.T. Attri sir on behalf of organizing committee, Anand Agriculture University, Anand, NAHEP, and on behalf of participant. So, welcome, sir, in Anand Agriculture University once again. You have visited so many times in Anand Agriculture University. So now I hand over mic to Dr. S.T. Attri sir. S.T. Attri sir, please.
Yeah. Thank you, Yadav Sahab, Manoj ji, and all delegates for this conference or training. So, thanks, Yadav Sahab, for kind words. And as you are aware, and I am well aware, that Anand Agriculture University is one of the pioneer agriculture university which has contributed to the national development, particularly research, education, training, all the three forms of uh, uh, works which is expected from the any agriculture university. So thanks for invitation and this opportunity to talk this august community. So during next 1 to 2 hours, then we'll be mainly talking on the agenda or the topic. I'm just sharing my screen. Yadav Sahab, Now screen is visible.
Not yet, sir.
But, okay, screen is paused. Why? Okay, now it's visible. Hello.
Okay, just sir, it is coming.
Okay,
I think
just
so.
see. Okay. I think it should be okay now. No.
No, sir, it is not visible in.
Okay, okay, just a moment again then. It is coming now.
Yes, sir. Yes, sir. Now it is perfect, sir.
Okay. Thank you, Yadav Saab. And what is mentioned, we will talking on climate risk scenario in agriculture. You are aware that climate has become a very important component, not only in the lives of us, but lives of everybody, whether it is human being, plants, animals. It affects every sphere of human activities. So why this climate and environment, they are so important? This is due to the reason that World Economic Forum is a body which brings a report every year on 15th January. uh, so last report was brought on 15th January 2020. Next report will be coming on 15th January 2020. They brings what are the top 10 risk in the world. So if you take with the serial wise, that number one threat in the world is extreme weather, number two climate action failure, number third natural disaster, number four biodiversity loss, and number fifth human made environmental disaster. So five threat, most important threat in the world, they are related to environment. First five. Somebody's mic is unmute. Kindly mute that. So five.
आवाज जा रही है.
Hello. Yeah. Yadav sir, audible na?
Yeah, sir. Clear.
Okay. Thank you. So five topmost threat, they are related to environment. If you go with other threat, like on daily basis, you hear on TV or see on the net, internet, data fraud and theft, cyber attacks and water crisis. These things, they are at 6, 7, 8. But most important are extreme weather events, climate change, and first five related to environment I just mentioned. And at that time, because this COVID came February or March, what will be its impact? We can have its, I will say, ranking in next year, next month. And this is so important because between 1998 and 2007, 5.526,000 people lost their lives during this period due to extreme weather events, and even economic losses were of the order of 3.47 trillion US dollars. And out of this, 97% losses were due to extreme weather events. You can say, because on daily basis, you see somewhere extreme is happening in Chennai, extreme is happening in Patna or Uttarkashi, or even Jodhpur, sometimes in Bangalore, sometimes in say J&K, somewhere heavy rainfall, too much loss. Even in insurance industries, they had a big loss even in 2018 of the order of 135 US billion dollars. This climate change, this climate subject is very new, and only you can say this is 41 years old subject. This was no much concern was there before 1979. So first meeting, FWCC mean First World Climate Conference, was held in 1979 in Geneva, Switzerland, where all scientists of the world met, and they were agreed that definitely there is scientific knowledge, there is science behind the climate change, and we must do something. And based on the recommendations of all these scientists from the globe, this intergovernmental panel on climate change was established in 1989 by United Nations Environment Program and World Met Organization. But this was the scientific view which all of us are discussing. Then second World Climate Conference was held in 1990 to make political class aware. Prime Minister, President, Environment Minister. Unless political class will agree to this climate change, money will not come. So they agreed, and global climate observing system that was established, that all of us must do something, must observe climate. And the third World Climate Conference held in 2009, then it was agreed that, okay, now 30 years down the line since 1979, we must do something, and every penny spent must be for societal purposes. And then it resulted into the formation of global framework for climate services, and 5 areas were identified. Main is agriculture and food security, water, disaster risk reduction, health and energy. So agriculture and food security is very important, and this is the main component where global research and discussion is going on. And one thing like weather and climate has no boundary. What is happening in Pakistan, that will be affecting us. What is happening in India will be affecting Bangladesh, or like that, and vice versa. So we cannot go to Pakistan to observe. Pakistan cannot go in India to have observations of the climate and weather. So what's the option left? Then there must be an agency which can have data from all parts of the world. So this global climate observing system, 4 agencies were assigned this job: United Nations Environment Program, World Meteorological Organization, UNESCO, everybody knows, United Nations Educational, Scientific and Cultural Organization, and finally International Council of Scientific Union. 4 agencies were given the responsibility to collect data all over the world related to atmosphere, related to ocean, related to land. So land, ocean and atmosphere, all global data should be received by this body, should be shared with different countries, so that what is happening to the climate, what is happening to weather, what are the risks. And if you will go with this figure of IPCC, Intergovernmental Panel on Climate Change, which Dr. Yadav mentioned a few minutes back. So this figure is from more than 10,000 station data. Red mean warming and blue mean this is cooling. So generally world is warming, and there is no doubt. Unless we put the data, nobody will agree to us. We have to put hard data, measure data, and then analyze data and give information to the public, to the government. Unless with our saying, nobody will agree to that. So there are 2 methods: either we observe data or we observe signals. So this is the 10 warmest year. If we take since 1988, 2016 has been warmest year so far in, say, last 140 years. Then 1919 was the second year. Now a report came on just a week back on 3rd December by World Met Organization that 2020 they have taken data from 1st January to 30th October. So based on these 10 months data, this 2020 will also be the warming year, maybe one of the 3 years, 2016, 19 and 2020. So after full year, let's see where it goes. Even if, because you see last 10 warmest year are in 21st century, every year is breaking record of the previous year. If you take data from 2006 to 2015, global warming was of the order of 0.86 degrees centigrade. If you take more recent data, 2009 to 2018, 0.93 degree warming. If you take latest 5 years, 2014 to 2018, 1.04. And Even if you take 2014 to 2019, it has come to 1.1. As far as India is concerned, 2016 has been warmest year in India also. 2019 was 7th warmest year in India, because particularly during last November, December, very cold spells were there. But there is no doubt that India is also warming up. But as far as rain is concerned, you see, green mean rain is increasing. This area, this. And somewhere this color rain is decreasing. So there is no pattern like temperature. So global is warming, somewhere rain is decreasing, somewhere rain is increasing. Total rain remains the same. So there are no trends, but where is increasing or decreasing. More extreme the events are increasing. Another thing, suppose I mentioned, either we measure temperature, rainfall, extreme events, or we see signal what is happening to the plants, what is happening to the animals, what is happening to our forest, what is happening to our glaciers. Like this is one photo from Uppsala glaciers of Argentina, 1928. This was the picture. Lots of ice and ice all over. But 2004, most of the ice that has disappeared. This is clear signal something is happening to the climate. I just mentioned heavy rainfall and give few examples. Similarly, in India, where blue cross are there, most of the places, extreme weather events, high rainfall in short span of time, say even more than 15 centimeter in 20, more than 12 centimeter in 24 hours. Such events are increasing. Most of the places see this area, except few areas. Generally, increasing trend in heavy rainfall events is there. Even land temperature is changing, sea surface temperature is also changing. If you take from the 1990 continuous, there is change in the temperature of the sea, and even sea level has increased by 20 centimeters since 1920. Because these things will definitely have impact on our agriculture and food security. If we go with the latest projection by Helle 2017, the projected climate which IPCC has come out, I will show some of the figures with that. So these are two things, like this 2030 projections and 2050 projection. Like 2030 impact will not be much, like those will be between say 2 to 3 to 10% decrease in the yield will be there. On different average yield is like this 8%, but even wheat decrease is more, maize is less, rice and soybean impact. But most of the crops except few, like in India also this winter potato or this G-nut and other few, only 2 to 3 crops, they show that climate change may be beneficial to them, but most of the 90 to 95% crops, so they show that impact will be negative. So 2030 impact is less, but 2050 impacts will be much more, particularly rice and maize impact will be much higher, maybe of the order of 33-34% will be there. And even if we take this impact of climate change in different parts of the globe, see, climate change could reduce global crop production by 9%. I just mentioned in previous slide, and 23%. This is the average for different crops by 2050. So 9% by 2030, next 10 years, and 23% is 2050. This is huge reduction. On one side, we are talking on the climate change and food security, and most of the models under the climate change scenario, they are showing that crop is going to crop productivity is going to decrease. There are risks to the agriculture production, risk to the food security, and even climate change is expected to lead to 1 to 3% higher annual fluctuation of the global production over next 4 decades. So even annual changes, so 1 year increase, 1 decrease. So this fluctuation is very critical because it affects planning purposes. One year deficit is coming, market. So in such cases, there is always pressure on the markets, whether it is loss or it is in excess, because it highly affects our price system. If you go with the like this red color, so most of the places, see even India, also Pakistan, and this whole, most of the Africa, Australia, parts of the China, South America, North America. And I mentioned that some of the areas, particularly northern latitudes, why they are showing green? Because climate change is going to have beneficial impact for these areas, because many areas over these continents and countries, they are totally covered with the ice. Permafrost is there, permanent ice, and in the climate change scenario, so this ice will melt and more land will be coming. So lots of production and product will be there. That is why these areas will be are being shown in green color. I was just talking about global things. Now let's talk about the Indian thing. So India Meteorological Department, established in 1875, it is monitoring weather parameters, climate parameters. We have 550 surface observatories, then 680 automatic weather station, 1350 automatic rain gauge stations, radars, upper air network, and around rain gauge stations, 3,500. This fluctuation may go sometimes up to 4,500 stations. They are in research institutes, state government departments, offices. They provide data, rainfall data, and we also use it. And even daily data we are getting from many stations in Gujarat and including Anand, because that is, we are getting regular data. Automatic weather station is there, observatory is there. We are getting quality data from Anand. And based on this data, I mentioned that global temperature during last 100 years is of the order of 1.1 degree centigrade increase over the globe. But India also, it is showing increasing trend. This is 0.61 degree centigrade during last 100 years as compared to global of 1.1. But there is no doubt that India is also warming up. Another signal that if temperature is warming up, then what will be happening? We must get more and more heat waves, more and more high temperature. So if we take data up to 1990, less than 500 instances were there in the country when this heat waves were observed. During this next decade, 580 stations showed 580 heat waves instances were observed, and if we take next 10 years, 2000 to 2010, 670 instances were observed per year. So temperature, I mentioned that every year we are getting more and more warming due to climate change. So impact is increasing. So India also, I showed global increase. So India also, red show warming. These two areas, some areas where minor spots of cooling is there. Otherwise, most of the country, there is no doubt that India is also warming up. Another most important parameter to quantify climate change is rainfall, on which our agriculture productivity depends. You know that 75% of the rainfall in the country is being received during monsoon season. So during June to September. So generally, what is the pattern of the annual, that is pattern of the monsoon season? This is annual pattern, around 118 centimeter we get during the country. Total annual rainfall is there. As far as monsoon is concerned, this is 88 centimeter rainfall. See, green mean increasing. Many areas during last 100 year rain is increasing, but in some areas, particularly central India, rainfall is decreasing, and this is more cause of worry. Why? Because central India is mainly rain fed. If rain is there, we will have crop. If rain is not there, we will have failure of the crop. So country is more concerned due to this phenomenon. And this is if we go with the, I was showing monsoon and annual trend, if we go with the seasonal trends also, this is the winter season. Most of the country except these 3 subdivisions out of 36, we have divided India into 36 Met subdivision. 33 Met subdivisions, they are showing decrease in rainfall during winter months, January, February. And during pre-monsoon season, March to May, central India is showing, including Gujarat, showing decrease in the rainfall. Some areas, this area and this area increasing. So rainfall is decreasing here. But I showed that total rainfall in the country, this total rainfall remains the same. So somewhere it must increase. So post-monsoon season, October to December during last 100 years, there has been increase in rainfall because this loss is compensated by increase in monsoon rainfall. But this is more serious because we need more rainfall during winter season, which is crucial for our winter crops, wheat, barley, then brassica and other crops. So that is very important. And another things like break in monsoon condition, when we don't get say 10-15 days no rainfall in the country, and we get more and more rainfall either in the Himalayan regions where more flood is there in Bihar and other regions, and we get more rainfall in western Ghats of the country. So these 2 areas, Northeast India, Western Ghats and Himalayan region, they get more rainfall, and whole of the India plain region, we don't get any rainfall. We call this phenomenon as break monsoon conditions. Earlier, more and more break, if we go with the 1887 breaks were in the August, but during last say 80-90 years or 100 years, we are getting more and more breaks since 40, like 70 years, we are getting more break in July month. So it is more serious. Why? Because July month is critical for sowing of our kharif crops. If we get more break condition, no rainfall, our sowing will be delayed, and you are all agriculture people. If delay in sowing, definitely 20 to 25% in reduction is directly there. So this is not a happy situation. I mentioned we are getting more and more extreme heavy rainfall events like more than 10 centimeter in 24 hours. We are getting this. Even more than 15 centimeter, more than 10 centimeter rainfall in 24 hours, we are getting more or more such events. But small rainfall, 1 centimeter, 2 centimeter like this, 3 centimeter, number of events are decreasing. This is unhealthy for agriculture because we need light rainfall, light to moderate, 1 centimeter, 2 centimeter like that, so that whole of moisture, whole of water can go to our crops, our soil, it can percolate, it can recharge, water table also will be maintained. But because when heavy rainfall in short span is there, more flood, more runoff will be there. But because total rainfall remains same and we are getting these more numbers, so these number will be less. Even if we go with the temperature variation in the Indian Ocean, I mentioned land temperature is increasing. It is of the order of 0.61 degrees centigrade. Maximum temperature increase is around 1.1 degrees centigrade, and minimum temperature increase is of the order of 0.2 degrees centigrade. So more increase in maximum temperature up to 80, there was decrease in minimum temperature, we were happy. Okay, maximum is increasing, minimum decreasing, no problem. But for last 40 years, minimum is also increasing. So that's more cause of worry. Even if during under this climate change, more and more heat waves and cold waves. So both they are showing increasing trends because more extremes are coming, temperature is increasing, and even during winter we get so many cold waves. If we go with the cyclones, number of the cyclones during last say 130 years, trend is decreasing, but if we take fury, power, violence, that is increasing because sea surface temperature is increasing. So cyclones, they are becoming more and more violent, more furious. And if we go with, this is IPCC report 2014, and they took 4 crops, this wheat, maize, rice, and soybean. So projected changes into the crop yields. So they have shown decadal. Earlier I showed 2030 and 2050, but if we take next 100 years data based on the decades and every 20 years slice, we take 2010 to 2019, 2030 to 2040, 2050 to 2069, then up to 89, and then up to 2090 to 2109. So this 20 years slice, we see the, so increase, decrease is more in most of the cases. Increase in yield is there in some of the crops I mentioned, because particularly permafrost areas and many upper latitudes, yield is going to increase. But globe as a whole, total impact will be in the negative. So this increase is there, this decrease is there, but so net there will be decrease in the rainfall. That's why I showed that 9 to 23% decrease is in there. Another thing, like many people told, okay, India is fine, but what is happening to our states? We are more concerned with that. Then we carried out a study on annual mean trends. This is the annual temperature. Except these 3 states, most of the states, state level also, temperature is increasing. There is no doubt. So India is warming up. As far as rain is concerned, state level, these states, decrease in the rainfall is there. Around out of 30 met subdivisions which we studied, 31 including both islands, states and islands, all the 29 states and 2 islands. So 15 showed increasing trends, 16 showed decreases. So no change, but even state level also, the central India is showing decreasing trends. And IMD brought a very recent in this year 20, this report was brought out in February 2020 using last 30 years data from 1989 to 2018. So based on this, 5 states, Uttar Pradesh, Bihar, West Bengal, Meghalaya, and Nagaland, they have shown decreasing trends in the monsoon rainfall during latest 30 years, where climate change impact is maximum. Even if we go with the annual rainfall, 5 these states and 2 more states, Arunachal Pradesh and Himachal Pradesh. So 7 states rainfall is decreasing. Other states, not much change, like change is within 10%. 10% plus minus we take as normal. Even if we go with the district-wise rainfall trends, so many districts in the country show significant change in the monsoon rainfall. Even frequency of the heavy rainfall events, you must have seen that significant increasing trend is observed over Saurashtra, Kutch, southeastern parts of Rajasthan, northern parts of Tamil Nadu, northern parts of Andhra Pradesh, and adjoining areas of Odisha, Chhattisgarh, southwest Madhya Pradesh, Bengal, Manipur, Mizoram, Goa, Konkan. So many places we are getting extreme, more and more increasing trends of the heavy rainfall events. I was there last time when I visited Ahmedabad. This issue was also brought by many agriculture experts, agriculture field functionaries, as well as university scientists. University, all the 4 vice chancellors were there. So this phenomenon was also brought, that we have seen this thing in particularly Gujarat. And if we go with the mean rainfall southwest monsoon, see, this is the things. The 30 to 70, because these are the less rainfall area and more rain. You know that Western Ghats and Northeast are more. But if we say district-wise trend, this red is decreasing and blue is increasing. So these areas, particularly central India, during last 30 years, the same trend, what was happening in the last 100 years, it is happening. If we go with the average frequency of dry days, so dry days are there increasing. So we are getting more rainfall in few instances, or number of dry days they are increasing or Gujarat, Rajasthan, Haryana, parts of Punjab and some eastern parts. Average frequency of the rainy days. So this is the thing. So number of days, extreme heavy rainfall, we are getting more. So this is the thing. So we are getting more heavy rainfall events over these areas. Trends in the frequency of dry days I have already mentioned. And this is frequency of the rainy days during monsoon. Number of these are heavy rainfall events. I mentioned that. Significant decrease in the blue and significant increasing. These are we are getting all over the country. And this was all what was happening in the world and in India. But everybody is interested what will happen in next, say, 80 years. So this is the latest projections, IPCC 2040 to 2065 and 2080 to 81 to 2009. So if we don't do anything, minimum temperature increase of the order of maybe 2.6 to 4.8 degrees centigrade, around 4 to 5 degrees centigrade increase can take place. Remember one thing, if there is increase in temperature of the order of 1 degree centigrade in 1000 years, don't worry. In 1000 years, less than 1 degree centigrade. But if it is more than 1 degree centigrade in 1000 years, it is a highly cause of worry. And you have seen that already in 100 years, 1.1 degree centigrade has increased. And what will happen into 10,000 years, maybe 10, 15 degrees centigrade increase. If 1 degree, everybody is critical. Take climate change as number one threat, extreme events, climate change. What will happen in 10 to 15 degrees centigrade increase? Even sea level rise can increase up to 45 to 81 centimeters. So we must do something to arrest this. And this is the pictorial picture of the temperature, all the models of the world. If we take all precautions, temperature will increase, no doubt. And everybody is thinking that it should not increase more than 2 degrees centigrade. Otherwise, many of the islands and 40% of the Bangladesh will be under ocean. If we do much thing, then figure will be like this. Just a moment. So figure will be like, so most of the models of the globe, they are showing this figure. As far as the rain is concerned, total rain remains same, but somewhere increase or more. So most of the model, they under warming change, they are showing rain is going to increase, temperature is going to increase, but there is more cats. Variability will be more. Sometimes more rainfall, sometimes less rainfall. So more drought and more floods will be there. Both are detrimental to agriculture production and food security. Another report by our sister organization under Ministry of Earth Sciences, IIT Pune, they brought out this report in June 2020, and this average temperature, they also show that it has increased by 0.7 and could rise by 2.7. In the best case, we do all the things, and in worst case can go up to 4.4 degrees centigrade. Even sea level is also rising more over Bay of Bengal, and even temperature of the warmest day and the coldest month, they have also increased. They have shown it. Hello. थोड़ी देर बाद meeting. So temperature of the warmest and cold months, I mentioned that we are getting more and more heat and cold wave. Even summer monsoon has declined by 6% in Western Ghats and Indo-Gangetic plains. With this study temperature increase, I mentioned, even if we take two slice 2040 to 2069, temperature is going to increase in both the spells. Then more frequent dry spells, 27% higher during this period relative to previous period we will be getting in the coming days. local climate change, increase in air pollution, change in the land use pattern, increasing stress of the climate change in ecosystem, freshwater resources and agriculture outputs. They have been projected and model being used by IITM. Now this will be the part of the new report of IPCC, which sixth report will be coming. These are the three reports by IPCC, one on the science, one on the vulnerability, and third on the mitigation. These are around 3,000 pages each books. So that will be coming in 2021, first in April, then July, October, and their synthesis will be coming in June 2022. So next year, IPCC report, you can say this is the Bible of the climate change. So this were all about risk, climate change, risk in how they are being changing, how they are being projected, how they are being observed different parts of the world, how they are affecting our agriculture. In next 20-25 minutes, I will be mainly focusing on that part. So climate, if we go with the challenges of the climate challenges in agriculture, one is climate related disasters, drought, floods. So we are experiencing this, and agriculture is directly impacted by this. Then high incidence of pests and disease. We are getting more and more pests. They are becoming more and more virulent. Then increasing demand of water. You are all agriculture people under warming scenario, definitely demand of water will increase, and most of the model have projected water is going to become less. So need to increase agriculture production. Our population is increasing. We already have 135 crore people, and in next 3 years, after 2013, 2023, we will be overtaking China. India will be the most populous country in the world, and our population is increasing. Same time, climate change is there. Agriculture, land is decreasing. So under these adverse scenario, we have to increase productivity. Then another challenge is effective utilization of available information and forecast and build capacity of farmers to bring these back. This is the most important for which these trainings and these workshops, they are being planned. So information, what is available, it must be disseminated to farmers in real time and in their language, user-friendly language, so that they can understand it. Then another challenge is enhance water use efficiency and reduce climate sensitivity. That is very important. So all agriculture experts, our agriculture scientists are there. We must do quality research on these issues. Then assess climate suitability to introduce new crops and alternate crops. So everybody is talking nowadays because wheat and rice. Now we have lots of surplus wheat, surplus rice. So it is, nobody is taking that. It is in the storage. It is being destroyed. So, but this is all surplus is there. So, but at the same time, we are importing oil seeds and other of the order of 1 lakh crore. So we must have to have the new crops, suitable crops where these can grow, these can sustain climate based on these things, based on these research. So new crops, suitability windows, suitability area, they needs to be more and more research and more focused. Another thing, another challenge is lack of climate knowledge, particularly our user community, clear understanding of the forecast and lack of the confidence to make decision based on the forecast are the top constraints. Sometimes see, this is the rainfall. Generally, we give quantitative terms. Say in Western countries, they show 40% chances of rain, 50% chances of rain, light rain, moderate rain. So that is very difficult because farmers have to use inputs. So clear understanding how are the chances, 80%, 40%, whether it is light rain, it is moderate rain, it is heavy rain. It can be on 1 or 2 places at 0 to 1 to 25% area, or few places 26 to 50% area, or many places 51 to 75% area, or almost all places 76 to 100%. So we must know all these terminologies and our how weather is interpreted, what will be the exact forecast and realization of the weather. These are the challenges, and we must understand and we must make understand our user community, which is farmers. You are aware that as far as forecasts are concerned, they are being used for different purposes. So graduated response to disaster risk. For the risk, we need, say, if we give monsoon forecast or seasonal forecast is there, 3 to 4 months forecasted in advance. This is mainly for strategic planning readiness. Which type of crops for this monsoon, drought will be there or flood will be there, or excess rainfall or deficit rainfall or normal rainfall. So we need to plan particular for planners and university top officials that this will be the weather, general weather, more rain or less rain. So we go which type of the crops. But say tactical decision like prepared a fortnightly forecast. So next 15 days, there may be more rainfall or dry condition will prevent what should be taken. In particular, farmers, farming operation, what will happen in next 3 hours, we call now cause strong winds may be there, hailstorm or maybe there, strong winds may be there, thunderstorm may be there, heavy rain may, what farmers should do particularly for the high valued crops. And even medium range forecast, you are all getting 5 to 10 days forecast we are using in all our this Agromet bulletins. We are now implementing Gramin Krishi Mosam Seva project. Earlier it was called, say, Agromet Advisory Services. So that is a very important project. And remember one thing, agrometeorology is one of the oldest discipline in India. And in 1932, Agromet division was established in IMD Pune. This is the oldest Agromet division in the world. India is the first country to start Agromet division in the world. So, and lots of work has been going on. Since then, 1945, we started Farmers Weather Bulletin over All India Radio, what will your weather over this state. So then by 1970, people and state is big. So Agromet advisory services should be started at state, what farmers should do. This temperature will be this, rain is less or more, what farmers should do. So with the agriculture, state agriculture department, this services was started at state level. Then it was felt that state is big area, we should start at agroclimatic zone level. So there are 130 agroclimatic zone in the country. So since 1991, this service by NCMRWF with Agriculture University and Anand and other universities were first to start this service is in 1991. So agroclimatic zone level, this service was started. Then it was thought agroclimatic zone is big area, we must go to district. So 2008, this was started by IMD and NCMRF services is merged. So district level we started in 2008 for 636 district. Then 2018, we found that there was need and there was demand that even district is big, lots of areas in the district. We must have block level services. So we started in 2018, 2000 blocks now. In 2020 now, this is operational service and more than 2,200 blocks, they are issuing block level services. So I will just mention. Why it is so? Because if you go with the 1990, I said that we started on this previous slide, agroclimatic zone level, because resolution of the model was of the order 250 kilometers. What is happening in 250 kilometers, that is was similar. So lots of modeling improvement, then computing power, and you are aware, may be aware that at this time, fastest computer, most powerful computer, India, IMD or Minister of Earth Sciences, it has fourth. Japan, UK, Japan, USA, UK and Japan and India comes fourth. So we have very strong powerful computer of the power of 10 petaflops is there and it is being augmented further. So resolution was 250 kilometers, then reduced to 150, 75, then 48 kilometer, 48 to 50 kilometer in 2018. Then in 2009, further reduced, and in 2017, when block level, 12 kilometers around block size, 50 kilometers around district size. So because we are able to forecast at this level of block. So block level services have been started. And now we are also testing models for 5 kilometer, 3 kilometer, 1 kilometer, so that in future, this forecast has to go to village level. This is existing agromet advisory services to farmers. So you may be aware that we use global models. We give forecast for next 5 to 10 days. This forecast we send to our state centers. They evaluate it and give to Agromet field units, which are being established at Agriculture University, ICR research institutions, and couple of IITs. These are 130. So they give earlier, they were giving forecast and agro advisories. What farmers should do based on these weather parameters, they should go for irrigation, they should go for pesticides or not, they should go for fertilizer. Whether demand is there or demand is not there. Based on the weather, these advisories, they are being disseminated, they are being prepared by agriculture scientists. So then this advisory is being disseminated to farmers. 43 million farmers, they are getting like 4.3 crores. They are getting bi-weekly SMS, from SMS also through Kisan portal of Ministry of Agriculture, 34 through Kisan portal, and other, they are private agency, IFCO Kisan Sanchar Limited, NGOs, Reliance Foundation. This advisory also going full advisory, state extension services, DD Kisan, newspaper, radio, state agriculture universities, state department of agriculture, IMDL, all websites are there now. More than thousands WhatsApp groups are there, have been formed by AMFUs, and now district agromet units, DAMUs, I will mention about that. They are also sending this advisory. So our purpose is to reach all farmers. So another thing, like this is the Meghdut app. So 1.5 years back, this was established last 27th July. So this is initiative of IMDICR jointly with Agriculture University. So this is in local languages. This is English, but it is all available all over the country in local languages. Weather is there, what farmers should do. So advisory is coming on this app also, you can see. Even State Agriculture University or AMFU have taken lots of steps to popularization of this MAC. This app is very strong. Around 2 lakh already downloads are there, and I request all of you that you must download this Meghdut app. This is both available on Apple as well, iPhone as well as this Android. So full bulletin is available for and forecast for next say 5 to 10 days. So you must use this, and also tell farmers and users to download this. And even other ICT based dissemination by some of our AMFU, like this is from E-Mosam Seva from HAU Hisar is there, then Sonitpur is there, then even Chiplima, Gurdaspur, Kosali, Majian, Lambuchan. The different AMFUs, they have such type of the app they have formed, and many institutions, they have their these WhatsApp group, including Anand. So farmers awareness program, they are being performed by all agriculture field units, because at every AMFUs and district agromet units, DAMU, 2 persons IMD is supporting with the finance, 1 agriculture observer and 1 scientist. And because they are conducting farmers program in the villages this year, even around 1,500 places, these farmers awareness programs are there. I participated in one at Baroda along with the scientist of Anand Agriculture University. Dr. Yadav was there, Director Extension was also there. So lots of enthusiasm was among the, I should say, farmers. They were very happy with these type of the interactions. We tell them, we get their feedback. So what is the lacuna, what are the weaknesses of our bulletin, what should we do. So these type of the farmers awareness program, they are being conducted by Agriculture University, Agriculture Med Department. Another thing, a Damini app is there. So all details are on our IMD website also, imd.gov.in. If you write Mosam, it will also come. This is for lightning, because for last few years we are getting, unfortunately, so many deaths due to lightning. And you see who are in the field. Our poor farmers are in the field. Other people are in the houses, either in the factories or in their shops. So farmers is most poor. So we must do something so that life and property of the farmers must be safe. So this is another app for lightning. Kindly see that. So I mentioned that 130 Agromet field units, they were there in the country to provide this district level forecast. Then based on the requirement of the Niti Aayog and then feedback from the farming and agriculture communities. So it was planned that we should have more units. All districts should have one unit. So 660 district units were planned. So next 530 units all will be at Krishi Vigyan Kendras of ICR, Agriculture University and others. All 530 units will be at KVKs, where one agrometeorologist will be there. We'll call him subject matter specialist, agrometeorology, one agromet observer. Now, these are being recruited. Then agro AWS, all KVKs and all agriculture university, all 660 districts, all AMFUs and DAMOs will be installing one agro AWS. So in addition to normal weather, automatic weather station, it will have soil moisture up to 1 meter depth at different depths, soil temperature up to 1 meter depth, and then this sunshine duration, because these three parameters, they are very important for agriculture. Then even the soil moisture gravimetric lysimeter, we are requesting all AMFUs to purchase it, and weekly data measurements will be there so that we can test these automatic weather stations also. And another thing, earlier the bulletin, Agromet bulletins, advisory what farmers should do in say next 5 days, those were prepared by IMDs, agrometeorologist or this technical officer or scientist at AMFUs or Agriculture University, along with other scientists like pathologists, soil scientists and others. But because they are the university now, district agriculture officer of all districts, they are part of this system, because they get what is the state and stage of the crop, how much crop sowing is there from their field station. So now they are part and parcel of this service. What we should do, I mentioned that now we have a block level advisory. So what we need for preparation of these block advisories, online reception of Agromet data and information. So we must get this. Preparation of high resolution medium range weather forecast, which I am supplying. Then Agromet products like NDVI, evaporation maps, radiation maps, temperature maps, and other maps. Then panchayat level crop information from state district agriculture officers, content and preparation of Agromet advisories, techniques, tools, product development, because R&D support is needed. Once bulletins are prepared, then there is very important, they must reach to the farmers in near real time, unless there is no meaning of all these actions. And farmers feedback and evaluation mechanism, that is very important. What farmers need, unless we know that, then whole things will go in doldrums. So if we go with the block level Agromet observation, there are present system, there are two. I mentioned that one is district level observatories, manual as well as automatic weather stations in universities, by IMD station and research institute, and another thing like daily rainfall monitoring scheme from state agriculture department, where only rainfall observatory is there. But we have the plan, I already mentioned, we will put agro AWS, all the AMFUs, Agromet field units, and Agromet district Agromet unit as district level. So to measure soil temperature, extreme weather events, so that because heavy rainfall is there, lightning is there, frost is there, hailstorm is there, because we have to observe them, because no instrument can observe them. So these are visual observation. So we have to have observation. Our scientists and observer, they will be taking observations. Then satellite based soil moisture, now it is being calculated. This will be used in the future. District or soil layer information should be available, because water requirement is highly dependent on the type of the soil. Real-time crop observation, then collection of data by Krishi Vigyan Kendra soil crop agronomic practices. So block level, I already mentioned that at present we have 660, and district we have to go to 6,500 to now new 7,000 blocks are there. Forecast is provided on 8 parameters: rainfall, maximum minimum temperature, wind speed, direction, relative humidity, both morning and evening, maximum minimum, and cloudiness. And based on these data and forecast agriculture advisory is prepared. But in future, suppose at present we are giving block level. So there may be 8-10 blocks in a district. So one unit is preparing, say 10 bulletin on regional language on Tuesday and Friday. But if you go to village levels, there may be 100 to 200 or 400 villages. It is not possible to do manually by a scientist. So we have to have automatic system so that it will observe weather. Observed weather will feed into the system, expert system, decision support system. Then agriculture information is there, so it will churnate the information and will bring out with the automatic advisory that farmers should do this. Then our expert panel, our agriculture expert, they will see that how accurate is this, any modification is needed, they will do, otherwise they will send the advisory. So there is need of this automation, otherwise we can't go to efficiently at block level and at no chance at village or panchayat level. So greater challenges are there, greater specification is required, increased granularity and customization of weather forecasting and tailored advice, because farmers want this village farmer or this block farmers advisory will be different. It must be, at present we are advisories push driven. We prepare, we send to farmers, whether they are using it, how useful is that. From this push driven, it should be pull driven. We prepare advisories, farmers should see our agriculture or IMD website, okay, this is good, we must see this advisory. It should change from push driven to pull driven. Then moving eventually to farm level, I also mentioned that from block to village 11, we have to go a day, that what farmers should do, what is in his field, 5 acre, 10 acre, 2 acre, 50 acre, what will happen, what will be the weather over this region and what he should do. So I mentioned that for this purpose, we need to automate the process. Already I mentioned that greater localization and downscaling of the things, then reduce dependency on specialist input, significant reduction in cost will be much reduced, and specialized inputs we have to generate. If we go with the agrometeorology decision support system, these are the input parameters I mentioned, that temperature, relative humidity, rainfall, all these parameters, and another biophysical parameters like soil fertility status, soil texture, moisture, field capacity, and PWT, available soil moisture, crop variety, phenological stages, crop duration, root length, density, crop coefficient. All these are critical parameters. They have to be collected and feed to the expert system for automation. For this purpose, IMD, with the help of RIMES Thailand, we have this prepared Agromet decision support system. This is overview, like daily observed data will be going into the system, then forecast from our different modes at 3 to 3 kilometers, 10 kilometers, and even extended range for weekly by 2 weeks to 4 weeks, that is going. All these based on the weather, then agriculture information, location, crop variety, crop weather calendar, contingency planning, all will be in this expert system. Then district level, block level advisories, forecast bulletins, even forecast verification, what you have given and how accurate is this, all will be coming out. So this expert system, decision support system should take all these things. This is the overview page. This will be like this, like 10 days, 1 2 3 4 5 6 9 10 days, rainfall, max temperature, minimum temperature, relative humidity, wind speed, wind direction, cloud, all these things, any district, any state, you just click it, you go on our this system, and you can see your state, your district, your blocks, all these 10 days forecast and observation that will come in. Even we can have each block, each district, what is verification, what we have given, how accurate. So these are the values. You can see value, you can see graph. Even we are also using this dashboard, how much, how many units they are preparing bulletins, how much it is accurate. So even all these bulletins, they can be downloaded also. I mentioned that district level advisories, block level advisories, all state, all district block, that is already in this system. We can go to the system and can see advisory into this. This is any example, just go to any state, any district, any block, and you can have this advisory prepared by agriculture experts. Even this is, if we go with the block level, I mentioned this 5-day, all the parameters, rainfall, both temperature, both humidity, wind speed, wind direction, cloud cover, daily values are there. Based on this, what farmers should do, alert is there. This is English and regional languages is there. This is just sample advisory. This is in Maharashtra and as well as English. This is the alert is there, and then full bulletin is there, weather is there, then this is warning is there, and full advisory will come so that farmers can see. For this purpose, important component is crop weather calendar. How crop will be progressing. So based on last, say, 20-30 years data, 10 to 30 years data, minimum should be 4 years. When suppose crop is sown here, this will be this stage, second stage, third stage. During these standard weeks, this is the germination and seedling, then vegetative stage, flowering stage, grain formation, maturity, when it will come. So crop is shown here, or crop is shown here. So stages will come. And during which weeks, if rain is more than this, dry spell here, drought, high winds, temperature, any hailstorm here, during these periods, this will be and this value is also there. Which period, anything around flowering, it will be dangerous, and even maturity, there may be loss. Suppose strong winds, hail is there. So these crop weather bulletins, crop weather calendars, they were prepared for all crops, but they were dynamic. They are on the average values. Now everybody is talking about dynamic crop weather calendar. When rain will be shown, rain has come when we sow the crop. So based on the growing degree, new crop weather calendar will be coming, and we will follow them. Just Agromet products I was talking. So these products, this is the list. Daily rainfall, weekly, monthly, seasonal, weather parameters, evaporation, soil temperature, standardized precipitation index, and these are the satellite products. Insolation, evaporation, NDVI, vegetation conditioning index, temperature and health condition, what is the state of the or health of the crop. So based on all these informations, ultimately, whether these are useful or not, what we should do with these crops, we will say, suppose you are preparing, I am preparing, we will say, this is the excellent advice, this is the good advisory, but I don't agree to this. Unless farmers say this is good, or independent agency, which is not from the agriculture university, not from the IMD, they evaluate these bulletins, they evaluate these services and come out with the findings. then we can believe that definitely this service is important. So agencies, third agency, National Council for Applied Economic Research is body. This is the independent agency. They carried out these surveys. First was in 2010 old, and two recent surveys, 2015 and 2020, they have come out with the reports. In 2015 reports, then they find that 20% economic benefits to all these surveyed farmers. They showed that our agriculture production has increased by 25% due to following of these Agromet advisory bulletins, and annual economic profit of 24% of the farmers cultivating these four crops. The survey was on four crops: wheat, paddy, sugarcane, and cotton. And these was assessed that 42,000 crore benefit is there to GDP annual for these four crops by following these Agromet advisory bulletins. And if we increase these advisories for all 22 principal crops, like these were four crops, so 22 principal crops they are in the country, so this benefit can go up to 3.3 lakh crores annually. With that, these bulletins should reach to all farming households around 9.5 crore, 10 crore. Now some figures are coming 12, 13 crore. So if all farmers will get, so this service alone has huge potential, huge benefit of 3.3 lakh crores. And recent survey, this our minister, he released this report on this last month itself in November. This report was released, 2020 reports. This is also by this independent agency NAECR. They found that 98% of the survey farmers, they surveyed in all different areas of the country, different state farmers, and find that 9 operations that farmers followed out of 9 advice, 1, 2, 3, 4, 5, how much practices they changed from 1 to 9, they changed practices either in the sowing or in the interculture or in the pesticides or in the fertilizer or in the irrigation. So 1 or 9, how much practices they followed from this weather. If they didn't see any weather, they didn't follow Agromet advisory, their income was of the order of 1.98 lakhs. If they followed 1 to 4 practices, so increase was of the order of 2.43. So 45,000 rupees income was there by following Agromet advisory and taking decision like whether they showed in the inputs, fertilizer, pesticides, and say even in irrigation. So 45,000 rupees was saved by each farmer. And if who followed 5 to 8 practices, 2.48 lakhs rupees they got. And if we followed all the 9 practices, there was income of the order of 3.2 lakhs crores. So around 1 lakh rupees by each farmers that was saved or that was earned by following these Agromet advisories. This is the finding of third agency, NACER. So this was all because climate impacts, is the implications, Agromet services, and then the assessment of the community. So thank you very much for patient hearing. If there are any questions, any doubt, you are welcome.
Thank you very much, sir. Thank you. Actually, there is no question in chat box, sir. But okay. I have one question.
Okay.
On behalf of trainees, sir.
Yeah.
Which area is most affected by climate change?
Hello.
Sir, in future, which area will be most affected by climate change, sir?
India or world?
In India, sir.
See, climate change, most of the models by all the 8 models used by Ministry of Earth Sciences, they show that temperature is going to increase. Then extreme events will be there. Even Himalayan region, they are very fragile. Even central India, that will be under more stress. Even western parts of the country, impact will be more. So most parts of the country, they will be impacted. Only few crops, particularly I mentioned that winter potato, then groundnut. For some parts of some areas under soybean, they will have less impact. But because extremes will be increasing, whole India will be under stress.
Thank you very much, sir, for nice answering. Sir, thank you. Sir, you have given detailed information about different climate change scenario, impact of climate change in different region of India, and different crops, and how we can minimize the climate change in different crops using different adaptation practices and mitigation methods. And sir, you have described in very detail what is the setup of IMD Agro Advisory Services and DAMU, how DAMU is working for farmers, and what activity is going on under GKMS project, sir. Sir, I know you are a key person to develop the DSS for automation of agro advisory for farmers, sir. I hope it will be very useful for scientists to generate the automatic advisory, sir. Thank you very much, sir, for your nice deliberation. And thanks again, sir. Once again, you have accepted, sir, our invitation in your busy schedule, sir. Thank you very much, sir.
Yeah, Yadav sir, one thing, what you mentioned just, that what are strategy they are available with us. One I explained about the Agromet advisory services. Another, like we have to have very efficient utilization of our resources. Our new R&D should focus on high temperature, salinity, and other water stress. Our R&D should be on that purposes. Then there should be integration of the things like we many times say integrated pest management. So similar way, integrated farm management, this concept has to take. And I mentioned this precision farming. So we must have to have what is the requirement of the farmers. So all our crop based on new things, like we have to use our future artificial intelligence, blockchain, then our cooperative farming. Then we and particularly Anand and Gujarat is leading all these things. So all options which are available with us, because climate change will be impacting, and we have to take actions like the crops which will release less and less greenhouse gases. And you may be knowing that already 4010 ppm of CO2 is their highest in last say 10 lakh years. CO2 was never more than 300 ppm. Now it is already 410 ppm. So we must do all the things so that release of these greenhouses will be less. We should have to have our plan like this. And the stress management is most important. Farmers, agriculture, scientists, agriculture expert should jointly working together so that we jointly can address these climate change threats. Thank you.
Okay, sir. Thank you very much, sir. Thank you very much. On behalf of Anand Agriculture University and NAHEP CAST and Department of Agricultural Meteorology. Thank you very much, sir.
Thank you, Yadav Sahab. Thank you all.